Might help if I unmute the microphone. Thanks for pointing that out. Thank you, Histo 101 and Chapman's biggest fan. That's going to be really awkward to continue saying during the stream. Hopefully you can hear me now. Oh, sorry, I could see the... yeah, okay, good. Sorry about that. Talk about technical difficulties as I was talking about before. So welcome along. Thanks, Red Cherry Waves. Thanks for coming along. So as I was speaking to no audio, what I was saying was that we wanted to introduce an extra level of support to our students. Hello, Zone 1 hepatocyte Lisa, thanks for coming along. Because histology is typically a subject or a topic that students find difficult. And so this would be an extra way for students to come and ask questions in real time or watch it later on in an asynchronous manner, so they can use it for revision. But one thing that I think helps with histology, you can often get lost along the way, and then it's really difficult to feel like you can catch up and actually go ahead and make, progress in histology. So a good way, I think, I'm hoping, is that we can actually model what I look for as someone with some experience in histology, and I can point out the things that I look for when I'm looking down a slide, and then be able to point them out to you, and that way that becomes familiar for you as well, something that you can actually take with you when next time you look down a slide or on a digital slide box or virtual microscopy or whatever. So, as I say, welcome along. Today we're going to start out because for my second year medical students, we've been looking at the digestive system, and we've started with the histology of the oral cavity, the esophagus, stomach and intestines. We're going to be having a look at some of those, and so that's a good starting point, and to give the students an opportunity to come and ask questions as well. So yeah, we thought we'd start there. So we're going to start off today with looking at the lip, which is of course the border for the oral cavity. So this is a low magnified section here of the lip. We can actually see these sort of strange structures on the outside here. This is actually the outer part of the lip, this sort of hairy part here. So these are all hair follicles, and you can actually see there's a nice example of a sebaceous gland here. So these are actually all of the living cells of the sebaceous glands, and they empty their secretion into the space next to the hair follicle, and then that would empty onto the surface. So this is our normal skin, hairy skin, stratified squamous keratinized epithelium. You can see the keratin layers here, or hopefully you can. So if we zoom out again, so here we've got the hairy part of the skin. If we continue down, we see sort of an end part here where we no longer have hair follicles or any glands whatsoever. So this is this part of the lip here, which is known as the orocutaneous border. Now some textbooks refer to this as the vermilion border. I'm trying to move away from that terminology. You can ask me why a bit later. But so this is an area, this part of the lip, known as the orocutaneous border. It doesn't contain any glands, so it actually is a dry area, and in order for us to keep it moist, we actually need to keep licking our lips and so on. So there's no sebum like we have in the hairy skin. These are the sebaceous glands here. To keep the skin moist, we actually need to moisten them with saliva, and of course that leads to our lips often, as a consequence, drying out and things like that. In the center here, we've actually got some skeletal muscle fibers. These are skeletal muscle. These are part of the orbicularis oris. Orbicularis oculi is the eye. The sphincter around the mouth. That, of course, enables us to purse our lips and close our lips and so on. So that's at the core of the lip. If we sort of continue our work down, we're actually still stratified squamous keratinized epithelium. So we've got our layers here. Here's the stratum granulosum and our stratum corneum here. So this is the outer dead layer. So we sort of zoom out here. We can actually see quite a dramatic change in structure of the epithelium in this region here. So we go from this keratinized epithelium to a non-keratinized epithelium, and it's really pronounced by the thickness of that epithelial layer. we now also have more nuclei present within this layer. So this is stratified squamous non-keratinized. The fact that we have nuclei present here indicates it's a non-keratinized epithelium. In fact, what we're probably looking at is a sort of a parakeratinization. You can see that the cells are very acidophilic here, meaning that there's probably some keratin there, but the cells haven't actually undergone cell death like we saw in the skin part. Over here, you can see there's no nuclei present here, so these cells are completely filled with keratin, and all of their organelles have died and degenerated, and so we've got basically cell membranes filled with keratin, whereas over here we can actually see nuclei to the surface. So there's keratin there, but it's actually not killed the cells, so the cells are still living in this layer. And then that parakeratinization appearance sort of will begin to disappear as we move down. So sorry, we'll zoom out again. So this is the inner part of the lip, so sort of lining the oral surface. So it's present in a moist environment. So we've got a stratified squamous non-keratinized epithelium. It's able to withstand abrasion, and of course on the inside of the lip, whenever you talk, your lips rub against your teeth, and there's a potential for abrasion there. So by having the saliva in this region and this very thick stratified squamous non-keratinized epithelium, it gives us a bit of protection. So where does that saliva come from? Well, there's a number of different sources of the saliva in the oral cavity. One of those is actually the minor salivary glands, and if we sort of zoom along here, we'll hopefully begin to see evidence of some of these. And this is some of what we call the labial minor salivary glands. So these are actually mucus secreting glands. You can see the very pale cytoplasms. These are some of the ducts which are carrying their secretions, and they would carry the secretions all the way to the surface out here. You can see some blood vessels over here, but eventually they'd empty their secretion onto the surface there. So these sort of minor salivary glands are scattered throughout the oral cavity, and they're just generally named where you actually find them. So these, because they're in the lip, would be called labial. And we have some on the inside of the oral cavity, and these are known as buccal glands because they're part of the buccal surface of the oral cavity. We know the buccinator muscle is in that region, helps to keep your lips closed and keep your food sort of between your teeth. And then if they're associated with the tongue, then of course they're known as lingual accessory salivary glands. So that was a quick overview of the lip. Does anyone have any questions about the lip? We might move on to have a look at some teeth, some developing teeth. If anyone doesn't have any questions, we're quite quiet in the chat room there at the moment. So hopefully it's still working. James, can you just test the chat room? Yeah, just type something in just to make sure that the chat's still working. Otherwise, yeah, we'll just keep moving forward. And if you have any questions along the way, please pipe up. Working all good? Oh, great. Thanks very much. Go for the teeth. All good. Thanks, Luke. So just so you know, Dr. James Crane is helping me out here. He's one of our moderators. You can see he's got the big sword there next to his name in the chat. So that indicates he's a moderator, or at least to me. You can see.
No, you've made Histo 101.
Yeah, and you've popped up. See? You've got it. Anyway, so he's here. He's mainly here to, one, check the chat, but also let me know if I've missed something in the chat, because this is my first time trying to multitask, and you know, I'm not a very good multitasker, so he's working. Hi, Dr. Kath. Thanks for coming along. All right, so let's have a look at another slide then. So we're going to have a look at the oral cavity, and we've got a section here which is taken from an old specimen that we used to have lying around. I'm not exactly sure its origin, but it's a very informative slide, and it's of the fetal head. Yeah, James may ask questions too. So here we've got the fetal head. So here's the brain. Here we've got the two eyes. This is the nasal cavity, and here's the oral cavity. So here's the developing tongue. So here's the developing maxilla, and then the developing mandible will be down here. So we'll be looking in these regions for the developing teeth. It's a really fascinating slide because it gives us so many different things to look at along the way.
So Jamie, which slide was the lip? There's a question on the chat.
Which slide was that for the lips? Oh, slide 46, I think, for those of the CAM 202 students who are following along. Slide 46 in our digital slide box. Now, for those of you who are outside of our university, oh no. No. Sorry, I've just had a little pop-up which says the computer's about to restart.
The only way to solve that is just drag it onto another screen. It won't go away. Yep.
Yeah, but I don't want it to restart.
It won't restart. You've got an hour.
Oh, okay. Right. All right. So sorry for that. Yeah, so those of you with digital slide box access, unfortunately it's only available to our students at the moment, but we do have a team currently working on our digital slide box to actually make it available to the public. So what I'm really hoping is that somewhere down the track very soon, you'll be able to follow along with our actual slides, so the ones that I'm going through. Where was the keratinized layer in the lip again with hair follicles? Is that layer nearest the skin? Well, yeah, that's right. Sorry, everyone, we'll just go quickly back to the lip. Imagine we've taken this section here, imagine we've sort of taken the lip out and bisected it and then cut it off. And then placed it sideways, flattened on the surface. So this is the hairy surface, so this surface here. Then this is the thin skin, hairless skin. Here the orocutaneous border or the vermilion border, and then on the inside we have the oral or the mucosal surface. So you can see how thick this stratified squamous question is. Stratified squamous epithelium is. Down here we've got the accessory salivary glands, so you can tell as well, if you can't completely identify that as non-skin or stratified squamous non-keratinized epithelium, the region with these salivary glands, accessory salivary glands, is that oral surface, and then here we've got the hair follicles. Ariel, does that help answer your question? This is actually all skin except for the oral mucosa. So this is actually hairy skin, this is hairless skin, and then down here we've got oral mucosa here. All right, great, thank you. So as we're saying, the fetal head here, we're going to have a look at developing teeth in the jaws. Now, teeth actually, made up of a number of components. So it has a crown on the surface, which are made up of enamel, and that's like the hardest substance in the human body. And then the crown has the rest of the tooth with the roots, and then on the inside we have the cavity, the pulp chamber there as well, and then it's all sort of embedded within the structure of the bone of the jaw, either the upper jaw or the lower jaw, by various substances like the periodontal ligament and cementum, which help to anchor it into the bone so that your teeth are held in place very, very tightly. Now, the enamel actually comes from surface ectoderm during development, and we'll talk about I'll show where that comes from in a second. But the whole rest of the tooth actually comes from mesoderm or mesenchyme during development of this connective tissue. Now, so if we're going to have a look, we're going to look in the oral cavity here. We've got a couple of different teeth beginning development. Now, the first evidence of tooth, so here we've got the developing tongue here. You can see the developing skeletal muscle fibers. You can see them running in different directions. Now, the human tongue is characterized by being the only region in the human body where you have skeletal muscle fibers running in 3 different directions. And so that's why you have this sort of crisscrossing pattern that you can see in the developing tongue here. You can see these little projections. These are sort of little developing papillae on the surface of the tongue. But down here, so this is the oral mucosa, or developing oral mucosa. This is ectoderm. And can you see this sort of little downgrowth? It looks a little bit like a duct. This is known as a dental lamina, and this is the sort of first indication that a tooth is beginning to develop here. So it begins as this sort of development of this downgrowth of the surface ectoderm, and then if we zoom in a little bit, you can see how this is a mesenchyme out here. So this is primitive connective tissue, so early, very, very early connective tissue before it's completely differentiated. You can see it's actually beginning to thicken here. You can see how it's a bit denser right next to this dental lamina. This is the first indication of what's called the dental papilla forming. So the dental papilla is going to go on to form the pulp chamber and the root of the tooth and the cementum and the periodontal membrane. All of those other components except for the enamel is actually going to be derived from this layer here, this condensing mesenchyme. So this, as I say, is the first evidence of a tooth beginning development as a downgrowth of ectoderm. This is known as the dental lamina, and then this is going to become the dental papilla. So if we zoom out a little bit, you can actually see the jaw beginning to develop here. So this is a little bit of the mandible. This is developing bone. So you can see the osteocytes within their lacunae here. So this is the developing mandible. And there's a little bit of cartilage here called Meckel's cartilage in this region. You've got a developing salivary gland over here as well. You can see the branching of the duct system. So if we go up here, we've actually got a tooth slightly further along in development. So what I might do is actually rotate this around so we're actually looking at it sort of facing upwards. So hold on to your horses. Hopefully you don't get seasick as I rotate this around. So there's our developing tooth. So here's our dental lamina. Okay, and then now here's our tooth. It's further along development than the one we were just looking at. Now this structure here, this whole thing you can sort of imagine as the enamel organ. So this structure is actually going to form the enamel, particularly a cell type known as the ameloblasts, which are found in this region. If you sort of zoom in here, can you see these sort of quite tall columnar cells? These are the ameloblasts, and the ameloblasts are responsible for the secretion of enamel, which is, that, as I say, the hardest part of, or the hardest substance in the human body. And so they're going to produce the enamel. Here, this is the dental papilla. Eventually, there's going to be a layer forming on this side, which is known as the odontoblast layer. And the odontoblast is responsible for forming the dentin, which is a sort of a harder version of bone, I suppose, made up of these rods, big long rods. And so the ameloblasts are sort of facing downwards and the odontoblasts are facing upwards, and so as the ameloblasts lay down the enamel, the odontoblasts lay down their dentine, and so you get the crown forming and then you get the root of the tooth forming at the same time during development. Now this cute little thing on the side here, so this is what we call our deciduous tooth. This is the baby tooth, if you like. The first tooth that develops eventually gets lost, and then this little guy off the side here, this is known as the permanent tooth bud. So this is actually going to form the permanent tooth.
So Jamie,
Yeah.
sorry, there's a question from Lady Meagrave. What was the cell that made the dentin?
So the dentin, the cell that makes the dentin is known as an odontoblast. So if we can do this. Oh, I've just written in red. So, oh, this is really bad. I'm using the mouse here. This is really bad. Odontoblast. I haven't had any drinks. It's only 11 o'clock in the morning. I apologise. So Ariel's asking, is the pulp of the tooth defined as the neurovascular structures within the cavity of the tooth? Yeah, so it's the sort of chamber in the inside where the blood vessels, nerves and lymphatics lie. That's exactly right. The notes say the dental papilla further divides into form cementoblasts, periodontal ligament and tissues of the tooth root and cavity. But how is the pulp formed? And it's probably a little bit beyond than what we actually need to know, but I don't know the specifics about the formation of the pulp chamber. I sort of think of them a little bit like a hair follicle, I suppose. You know, we've got the hair bulb, and you've got the papilla, the hair papilla, which contains the nerves, and blood vessels of the connective tissue, and it almost looks a little bit like a hair bulb here as it's beginning development. But needless to say, the major sort of take-home message is that the enamel organ and the cells that form the enamel comes from the surface ectoderm, and everything else basically comes from the mesoderm. Those are the real main take-home messages. The pulp consisted of the tooth, root cavity, in the way it was phrased. All right, thank you. No worries. I'm sorry that the text was a bit misleading there. Hopefully it didn't cause you too much confusion, and hopefully now we've cleared it up. Right, so I was talking about this here. This is the permanent tooth bud. It's sort of a downward extension of this dental lamina. Luke has a question. Do the ameloblast and odontoblast directly contact each other, or is there a layer in between them? Well, of course, what happens is you can see here that the ameloblast first formed, they begin to secrete enamel. So by the time that the odontoblasts form, they actually, there's an enamel layer between them. So generally they don't touch each other. They do have these long, the odontoblasts have these long cytoplasmic extensions which extend out between the dentin as well. Same thing, there's a space in the final picture. So of course the enamel is going to be laid down, the dentin is going to be laid down, and therefore you're going to have enamel and dentin between the two layers. So they generally don't have a layer in between them. They don't touch. They don't interact with each other. So this is, as I say, is the permanent tooth bud. This is going to go to develop a new tooth over time that will eventually push this deciduous tooth out onto the surface, and eventually it's erupted and then shed there. Great. I'm glad that makes sense, Luke. Thanks for asking the question. So of course, if you imagine that this tooth is going to continue to develop, it's eventually going to move closer and closer to the surface. It erupts, you know, baby's teeth, and then once it actually erupts, you actually lose the enamel organ, and you lose any ability to actually make new enamel. So your enamel is sort of a lifelong thing. It's there until it goes away. I guess that keeps dentists in work, because if it didn't go away, then they wouldn't have any work. But once it's shed, it's gone forever. However, on the inside of the pulp chamber, we have a line of odontoblasts, so they actually can make a new dentin if they need to as well. So that was a quick overview of the oral cavity, of the tooth development. I think the other stages of development here are much the same stage. So here's our enamel organ, here's our dental papilla, and here's our bud of our permanent tooth connected to this dental lamina here. Does anyone have any further questions about tooth development? We really don't spend a lot of time talking about tooth development anymore, but it's kind of an interesting little area. So if you've got any further questions, then we can move on to salivary glands. Should we look at some salivary glands? Just looking at the major features of the different salivary glands. Okay. All right, so let's start with the parotid salivary gland. This is the big salivary gland that's sort of in front of your ears here, under your skin. Big, major paired salivary glands, and then it actually empties via a big duct in your near your upper second molar. So if you run your tongue on the inside of your mouth, you might feel this little projection, like a little I don't know how to describe it. It's like a little bump on the inside of your oral cavity and near the upper molar, second molar, and that's the opening for the parotid salivary glands. Now the parotid salivary glands is an entirely serous gland, and it's responsible for the secretion of salivary amylase, which begins carbohydrate digestion in the oral cavity. I don't know if you've ever had something very starchy before. here in Australia we have something called Sao biscuits, which a lot of, well, I was introduced to it by my grandma, who used to have cheese and crackers, and the crackers were the Sao biscuits, and they're a very starchy type of cracker. And if you put it in your mouth and you leave it in your mouth for quite a while, those starches are actually broken down by your salivary amylase, and it begins to taste quite sweet because they're actually breaking it down to disaccharides and things like that our taste buds can then actually detect. So salivary amylase comes from the parotid salivary gland. As I say, it's a entirely serous gland. It has a connective tissue capsule, which you can see on the outside here, dense irregular connective tissue. You can see some blood vessels and things. And then it helps to divide, it has lobes, which is then further subdivided by connective tissue into lobules. So each of these is a connective tissue septum, which originates from this connective tissue capsule here. So this is considered a lobule. So here's one lobule, here's another lobule, here's another lobule, and there's another one, and so on. So anything within here we would describe then as intralobular, because it's within a lobule. And then anything in the connective tissue in between is then interlobular, because it's between the lobules. And so within the lobules, intralobular; between the lobules, interlobular. And that terminology can be a little bit confusing. So we're going to zoom in here and begin to have a look at some of the features here. So entirely serous means that the cells are protein producing, and so they're actually producing an enzyme, as I say, salivary amylase. So they have a protein producing appearance, so the idea that the cells are kind of pyramid shaped. They have a flat base with a big round nucleus at the bottom, and then they peak at the top and then secrete into a duct at their apical surface, which that first duct is known as the intercalated ducts. So at the base of the cell, we've got the round nucleus and lots of rough endoplasmic reticulum, which is producing that protein, and then it's being processed by Golgi and then forms the secretory granules in the apical surface of the cell. And so sometimes we can get like a slightly different staining pattern where the bottom of the cell's very basophilic, stains well with hematoxylin because of the high density of the nucleus and the rough endoplasmic reticulum. And then the top of the cell can be quite acidophilic if it's storing those secretory granules containing the enzyme. But it's not always the way it works out, especially if, this cells have actually secreted fairly recently, then you don't have that apical acidophilia typically. So having a look here, we can see the nice round nuclei. The acini tend to form these more sort of circular structures with the nuclei at the base. It can be a little bit confusing. So here's one acinus. So it's made up of a number of these protein-producing cells, big, round, basally located nuclei. Again, here we've got them lined up along the bottom here. So they can be a little bit difficult to interpret as quite circular. You can see the sort of idea here. There's another acinus here. Now, this structure here, this is actually a duct. So this is one of the intralobular ducts that occurs within the lobule. This material over here, you need to kind of ignore. These are actually adipocytes, and so they don't really play a role at all in the gland's function. So we would say that then these serous acini are the parenchymal cells of this gland, meaning that they're the functional component of the gland. Whereas the connective tissue component is known as the stromal component or the supporting component. So lots and lots of serous acini, no evidence of any mucus acini here, and then we've got these various ducts found throughout. Now, the intercalated is the first of the ducts, which sort of carries the secretion from the acini. They can be a little bit tricky to identify because they're quite small. And so it does sometimes, here's one here. So you can see these cells look very different to these serous acini here. So this is an intercalated duct. They usually start off as sort of a simple squamous, very low cuboidal, and then eventually become the striated ducts, which have more of a tall cuboidal, low columnar type of appearance. So you see the nucleus is quite round here for this duct, indicating it's a cuboidal cell, even though you can see that the cytoplasm is probably a bit taller than we would expect for a cuboidal cell. So we saw that tall cuboidal to low columnar type of appearance. So the serous acini are drained by the intercalated ducts, which then go to the striated ducts. So there's another striated duct here. If we sort of zoom out and find a better picture of a striated duct, here's one. You can have a look here. This is our striated ducts. Intercalated ducts are always smaller than striated ducts. Yes, so they start out, as I said, as simple squamous and then become very low cuboidal, and then the striated ducts are always the bigger ones like this. You can see they're almost columnar in appearance, but their nuclei often sort of give a little bit of evidence of a cuboidal shape, even though some of them are a little bit elongated. Okay. Now, you might be able to make out some of these little basal striations. What these are basolateral membranous infoldings. What the heck does that mean? Well, if we think about a sort of a cuboidal cell.
So, Jamie, sorry, was that was a question here?
Hey, Jamie, was that intercalated to striated to interlobular lumen surface? Yes. So from interlobular you go to lobar ducts, draining each lobe, and then that has a main duct which empties into the surface of the oral cavity. So that's exactly right, MJ Green. Thanks for asking the question. So as I was saying, so the basolateral membranous infoldings. If you've got a cell which is cuboidal or columnar and it's sitting on a basement membrane, and at the top, if you want to increase surface area at the apical surface, you know problems. You can actually have microvilli projecting upwards. But if you want to increase the surface area of the membrane at the base of the cell, you've really got nowhere to go because you're sitting on a basement membrane. So rather than having projections outwards, what the cell does is it has projections inwards, and those are the membranous infoldings which we can see in these striated ducts. So they're actually a means of having an increase in surface area of the cell membrane at the basal surface so that you can have more ion channels and things like that. And interspersed between those membranous infoldings, we often find mitochondria, which are powering the ATPase ion channels to move substances against a concentration gradient. So mitochondria have lots of membranes, they have lots of enzymes, and they're quite acidophilic, and that accounts for the stripy nature at the base of some of these striated ducts. Now, it's not always completely visible, those striations, but generally any of these larger ducts, which you can see amongst the serous acini, are going to be the striated ducts. So you can kind of make out some of these striations down the bottom here. I don't know how well that's translating onto the stream there. So parotid salivary glands, entirely serous, have striated ducts. They're quite clearly visible amongst the acini here. Again, another striated duct here. Very pale, quite tall cells amongst the more basophilic staining serous acini. So if we have a zoom around, we might be able to see some of these larger ducts. So here we have some of these larger ducts amongst the connective tissue. So these are the interlobular ducts, and they're often sort of lined by a stratified type of epithelium. You can see the multiple layers of nuclei here. Here as well. So these are the interlobular ducts because they occur between the lobules of these salivary glands. So those are some of the features of the parotid salivary gland. If we go back to here, this is the submandibular salivary gland. What does it mean to say that interlobular ducts are initially cuboidal columnar but may be stratified? What happens is they increase in the ducts increase in thickness, and so they start out initially as a simple columnar and then eventually become a stratified cuboidal or stratified columnar type of appearance. So their epithelium changes to more robust structure as it moves outwards to become interlobular to lobar to eventually the main secretory duct. Does that make a little bit of sense? Does that make sense, Ariel? So they change from a simple epithelium to more of a stratified epithelium. They don't modify the secretion, so the intercalated and the striated ducts can actually modify the secretion. The interlobular, the lobar ducts don't modify, they're just sort of conduits. No worries, great, I'm glad that helped. So again, we've got, this is the submandibular salivary gland. So parotid was entirely serous. Submandibular is about 80% serous, 20% mucus. So if you can see mostly serous acini, when even at this magnification, it's very basophilic, which is a good indication that there's lots of serous acini. So if it's mostly serous with a little bit of mucus, then this is the submandibular salivary gland. So if we zoom in here, you can see our lobules again. So we've got our connective tissue stroma here. I'm not going to make any comment about the shape of this large duct here, but we move out here, we can actually see that it's predominantly made up of these serous acini. You can see these round, very basophilic structures. So these are the serous acini. And then here we've actually got a few mucus acini with some serous cells associated with them. Now, they normally sit sort of side by side. You've got a serous cell, a mucus cell, serous cell, mucus cell, not necessarily completely arranged like that. But when we process for microscopy, mucus kind of tends to expand. What it does is it pushes those serous cells out and they form this cap on the surface. And so they form these structures known as serous demilunes. So here's a serous demilune on this mucus acinus end here. Now, the way we can tell it's a mucus acinus, one is the cytoplasm's very pale staining, but two, the nuclei tend to be basally located and very flattened as well. So this is a mucus acinus and we've got a little bit of a serous cap on the surface. This is forming these serous demilunes, which means sort of half moon shapes. So here's our mix of seromucous glands. Again, we've got our striated ducts. So you can see the striations down here. So these are intralobular ducts. So those are our major features of the, there's a really nice striated duct here as well. You can see them throughout the serous acini here. Again, we've got a little clump of mucus acini, but predominantly the gland is serous with a few mucus acini and their serous demilunes there. This is a really nice region here. It's a nice example of a serous demilune here, over here and over here. And again, oh, nice striations on this one. Look at that. Very nice striations here. So this is a blood vessel on the left-hand side here. These are the striated ducts. All right, so that's the submandibular salivary gland, 80% serous, 20% mucus. And then we move to the third of the paired major salivary glands, and that's the sublingual salivary gland. And this sublingual salivary gland is 80% mucus and 20% serous. Now, the difference being is that there's no real sort of standalone serous acini generally in the sublingual salivary gland. They all exist as those serous demilunes that we were just looking at. So it's 80% mucus. You can see how much of these are mucus acini. Again, we've got that classic sort of stained glass type of appearance, very pale staining, cytoplasms, because there's lots of mucin granules here, basally located, dense, flattened nuclei at the base of the cells there. If we sort of zoom out, we might be able to see some evidence of some serous demilunes. They're not as obvious as we were looking in the submandibular salivary gland. So sometimes you need to do a little bit of searching around to try to identify here, like here, these little caps of serous cells on the surface there, these sort of round nuclei, which is typical of the serous components. And here we can see a couple over here as well. So what you're looking for is the round nuclei, more sort of acidophilic staining cytoplasm, which is typical of these serous secreting portions. Again, we got our intralobular ducts here. Now, some textbooks say there's no striated ducts in the sublingual salivary gland, but I'm not going to sort of say that there are intercalated definitely, and then the larger ones we just identify as striated ducts, although they tend not to have the typical sort of striated appearance like we were looking at in the other glands. But you can see how much is mucus. It's just all mucus, and then the odd serous demilume on the surface there. So those are the major salivary glands. You can create what I call a decision tree about whether you're looking at one of these major salivary glands and how you make the decision about where you're looking at. I've got some 3-minute histology videos on my YouTube channel if you want to check those out. So I talk about the decision trees, you know, deciding whether you're looking at an entirely serous or a mix of mucus and serous, and therefore then the composition of those, and then actually applying that decision tree as well. So I highly recommend that you check out the 3-minute histology videos on the salivary glands and the decision trees there, to help you make your own decision trees and work out what you're looking at. Now, before we move on, does anyone have any questions? We are starting to head towards the end of the stream. We've got about a quarter of an hour left before we have to close down, and this computer's going to close down just a little bit after that. So we might move to the esophagus, unless anyone's got any questions there. All quiet in the chat, so hopefully that's a good sign. So we're going to have a look at the esophagus now. Now, the esophagus is the first part of the gastrointestinal system that shows the typical sort of 4-layered structure, and we'll see that right from the esophagus all the way down to the level of the anal canal, and so the esophagus, the stomach, the small and large intestines all have these 4 building block layers that make them up. And those layers are the mucosa, which consists of the surface epithelium, lining epithelium, its underlying loose connective tissue, which is known as the lamina propria. Thanks very much, Histo 101, for linking to my channel in the chat there. It's really helpful. Were any taste buds visible before, or were they just primitive papillae or something? Thumb dude, yes, exactly right. So the tongue in that fetal section wasn't well developed enough to actually develop proper papillae, so they hadn't developed taste buds at that stage. That's a really good question. We can have a quick look at papillae before we close the stream. So if I don't remember, either James remind me or one of you guys in the chat remind me. So the mucosa of the layers consists of this lining epithelium, underlying layer of loose connective tissue, which is called the lamina propria, and then this layer of smooth muscle, which is known as the muscularis mucosae. So that's the mucosal layer. Then we have a submucosa, tunica submucosa. And then we have, which is largely dense irregular connective tissue and some larger blood vessels there. Then we have the tunica muscularis, which is the layer here. Generally in the gastrointestinal tract, it's made up of an inner circular outer longitudinal layer, although that varies in the areas, particularly the stomach. And then either an adventitia or a serosa. In this case, it's connective tissue, so it's an adventitia. You can see a nerve there and some blood vessels. I don't think they've preserved the adventitia particularly well here. So the esophagus is lined by a protective lining epithelium, which is have a look here. Thanks, James. Stratified squamous non-keratinized epithelium, big thick epithelium, nuclei all the way to the surface. You can see they're flattened on the surface, indicating their squamous appearance. Then we have our underlying layer of loose connective tissue. You can see lots of capillaries in this region. So here's our capillaries. And of course, they're going to be providing nutrition to the avascular stratified squamous non-keratinized epithelium on the surface. Here's our layer of smooth muscle of the muscularis mucosae. Now we're in cross section here, and these have been sectioned transversely. The reason we can see that they've been sectioned transversely is that the nuclei are round here, which means that the elongated nucleus, which we typically find in a smooth muscle cell, has been cut in half, meaning that the smooth muscle cells are coming out towards us on the screen. And so that means these are actually longitudinal running. And the esophagus is the only region that has entirely longitudinal muscle, smooth muscle in its muscularis mucosae. Here's the submucosa. You can see big thick bundles of collagen indicating it's a dense, irregular connective tissue. We can see larger blood vessels in this region. Now, depending on where this section was taken from, we may find mucus secreting glands or seromucous glands in the submucosa, but they tend to be more in the upper third of the esophagus and at the distal third where it joins onto the stomach. So the absence of those glands sort of leads us away from this being a section of the upper third or the distal third. Another way to tell whether we're looking at either the upper third, middle third, or distal third is the composition of the muscle tissue in the tunica muscularis. Are tunica muscularis and muscularis mucosae the same thing? Really good question. No. So the muscularis mucosae are specifically this smooth muscle layer that's associated with the mucosa. The tunica muscularis is the muscle layer on the outside of the organ. Or the muscularis externa is also another name for this layer on the outside here. So the muscularis mucosae is that layer specifically associated with the mucosa. The tunica muscularis or the muscularis externa is this outer layer adjacent to the serosa or adventitia. As I was saying, one of the ways to distinguish whether you're looking at a section of the upper third, middle third, or distal third of the esophagus is to look at the composition of the muscle tissue within the wall. What kind of glands do we find in the proximal and distal thirds of the esophagus? These are largely lubricating mucus glands. So in the upper third, they provide a lubricating mucus for the food bolus to move down, and then in the distal third, they're also mucus glands, but they're providing a protective mucus lining from acid reflux. So there's always sort of some form of acid reflux taking place, and so we have this thick protective mucus being secreted in that region to help protect it from that acid. So identifying which of the thirds you're looking at of the esophagus, in the upper third we have skeletal muscle in the tunica muscularis or the muscularis externa. In the middle third we have a mix of skeletal and smooth muscle, and then in the distal third we have only smooth muscle. So if we have a look at the muscularis here, we can definitely see that we have smooth muscle. Okay, there's lots and lots of smooth muscle cells stuck close together, lots of nuclei, elongated cells, very typical of smooth muscle cells. But if we sort of head out here, we can actually see interspersed, particularly in the outer longitudinal layer, so here's the inner circular layer, here's the outer longitudinal layer. Amongst this smooth muscle, we can actually see these very big acidophilic cells with the peripherally located nuclei. These are skeletal muscle fibers. So we've actually got a mix between smooth muscle, these are the smooth muscle fibers, and then we've got skeletal muscle fibers out here. So we've looking at here is a section of the middle third of the esophagus because we've got this mix between skeletal and smooth muscle. As it moves further distally, that becomes entirely smooth muscle and peristalsis takes over completely and helps to move the food bolus to the stomach. So really that's the major features of the esophagus there. Unless anyone has any more questions about the esophagus, we sort of zoom out here just showing some of these skeletal muscle fibers amongst the smooth muscle here. I always love seeing this. Such a bizarre thing to have skeletal and smooth muscle fibers together in the same place, I think. Personally anyway, I think it's kind of cool to see them side by side and amongst the same tissue here. But that's just me.
Also a really good way to see the difference between them.
Yeah,
histologically, right?
absolutely.
Yeah.
So James was just saying, if you didn't hear that, it's a really good way to distinguish between the two muscle tissue types by having them so close together, side by side there. Skeletal muscle fibers and smooth muscle fibers side by side. Does anyone have any questions about the esophagus there? So I think we do have another esophagus section here. We'll have a quick look at this one just to see if we can identify which of the three regions we're looking at, proximal, middle or distal third, just based upon the features. So here it's actually upside down, so we'll switch it around a little bit. Ooh, this one's nice. All right, so this one's longitudinal.
Quick question, James.
Yeah.
Are there any other ways to differentiate the third part?
The thirds.
Presumably,
Yeah. So epithelium's the same. One thing that differs along the length is the muscularis mucosae. Submucosa, I did mention that the upper third and the distal third may have mucus secreting glands, so that's how you can sort of tell those two, but you can't use those features because they're found in both regions, so you actually need to sort of keep that in mind. The tunica muscularis is the predominant way, but as I was saying, the muscularis mucosae, the part of the smooth muscle which lines, or the sort of outer layer of the mucosa, it starts off very poorly developed because, remembering we've got the skeletal muscle and the tunica muscularis, so it doesn't need much help to actually move that food bolus. But as it moves down and we get more and more smooth muscle, that muscularis mucosae becomes thicker and thicker and more prominent. So the thickness of the muscularis mucosae is also a good indicator about where you're looking at as well. So the middle third would not have submucosal glands. No, yeah. So you just saw that section, so that we just saw that middle third. There were no submucosal glands present in that section. I did have an idea for a little research project just to confirm that, because it's kind of interesting that there wouldn't be any along the entire length, but unfortunately no one decided to do honours. So it's just a question for future reference. So what we're looking at here is a longitudinal section of the esophagus. So here we've got a stratified squamous non-cratinized epithelium. This is not a particularly well preserved section because you can see that the loose connective tissue fibers are quite disrupted here. There's the muscularis mucosae. It's very disrupted, not a nice single layer like we saw with the previous slide. And then here in the submucosa, we've got all of these mucus glands. So these are the submucosal mucus glands here. So now, just even taking this as an indication, we're either looking at the upper third or the distal third. If we go out to the tunica muscularis, again, it's not very well preserved, but this definitely is not smooth muscle. We zoom in again, you can actually see some striations here. Hopefully that's coming up on the across the stream there. I think on the right hand side we can actually see some of these striations, and that's of course indicating that this is skeletal muscle. So not only is the outer layer have skeletal muscle, but the inner circular layer has skeletal muscle. So Hibiscus has asked, so in the proximal and distal 1/3 of the esophagus, are the mucus glands in the submucosal layer, or can they be in the mucosal layer as well? The secretory portions are located in the submucosal layer, and of course their ducts need to bypass through the mucosal layer to secrete into the surface. So while the glands themselves are in the submucosa, they will have ducts which will run up through the muscularis mucosae, through the loose connective tissue lamina propria, and then onto the surface. I don't know if there's any evidence of ducts. Kind of see evidence over here. Oh, there's a little duct. So you can see this little duct here in the lamina propria. So the duct portions will be emptying onto the surface, but the secretory portions are going to be found down in that submucosal layer. Does that answer your question, Hibiscus? Hopefully. The glands themselves are here, and then their ducts run along the surface there. Great, I'm glad that helped. Again, you can see some of the ducts here running up. So they obviously got to penetrate through this muscularis mucosae in order to release their secretions here. You can see this one winding its way up onto the surface there. So based on the presence of the mucus glands in the submucosa and the skeletal muscle fibers in the tunica muscularis, we can clarify that this is a section of the proximal third of the esophagus there. All right, well, we've just hit midday, which means that it's about time for the stream to end. So we will probably run another stream next week, where you can probably look at the stomach and intestines in that stage. I'm sorry we never got a chance to look at it. What we will have a quick zip at is the tongue. So we've actually got that on one of our demonstration slides here. So I apologise that we're not going to have time to go through the stomach and the intestines today. Lingual tonsil. Sorry, excuse me while I look for the section of the tongue. So if you remember, one of the ways to distinguish a section of the tongue is to actually look for skeletal muscle fibres which are running in many different directions. So here we've got our section of tongue. So we sort of, we can see our skeletal muscle fibres here running in 3 different directions. We sort of zoom in. We've got these big cells, big acidophilic cells, peripherally located nuclei. We zoom in, we might be able to, can you see those striations there in sort of longitudinal section? Kind of making them out, I think, on the stream, depending on the quality of your stream, I suppose. There. So then we go to the surface. Oh, look at these. These are awesome. These are known as filiform papillae. So filiform papillae are characterized by having these sort of points. And these are what we call the non-gustatory papillae. So they're basically like having fingerprints on your tongue. So they increase surface area for contact, and that enables you to move food around in your oral cavity. So we zoom in, we can actually see this is a stratified squamous, non-keratinized / parakeratinized epithelium, and these are the filiform papillae here. Projections upwards, a little bit like little eruptions on the surface there. If we sort of come down here, we see this large structure here. It's got these 2 deep crevices on either side. These are known as the crypts, and this is a papilla here. This is a projection on the surface of the tongue, lined by the epithelium, has a core of loose connective tissue. And so this is one of the circumvallate papillae, one of the big papillae in the tongue, sort of divides the tongue into an anterior 2/3 and posterior 1/3. And then on these lateral surfaces here, you can actually see these little rounded regions. These are actually taste buds. So they actually have these little openings on the surface here called taste pores. And these are bipolar neurons, which are each detecting their own modality of taste. So it might be one tasting sweet, one tasting sour, one tasting bitter, one tasting umami. Salty. One's tasting salty, and I think I mentioned in the lecture to the second year medical students, and those of you who aren't there, there's a proposed 6th taste modality called oleogustus, which is a proposed taste of fat, but that's still being researched at the moment. So these are bipolar neurons. So we have a mix, and it's very difficult to distinguish between the different cell types, but generally there's 3 cell types amongst these taste buds. We have the bipolar neurons, or the taste cells, which are detecting the taste. We have sustentacular or supporting cells, and we have basal cells, which are the stem cells. Taste cells have a lifespan of about 5 days. So every 5 days, the new taste cells are actually being created and then making contact with afferent fibers. And those afferent fibers are carrying the taste information, either if we're talking about the anterior 2/3 of the tongue in the facial nerve, or the posterior 1/3 of the tongue in the glossopharyngeal nerve. So associated with these taste buds are these serous acinar glands, and these look really nice. We have a zoom in. You can see the acidophilia I was talking about before, the idea that the top of the cells, that's a really good question, Ariel. So Ariel's asked, if circumvallate papillae are found anterior to the sulcus terminalis, why is it innervated by the glossopharyngeal? The demarcation isn't, a specific line, it's in that area. So as I was saying, the circumvallate, kind of the border between the posterior 1/3, so they're sort of the posterior 1/3, and then anything anterior to that is the anterior 2/3. But of course there's going to be a little bit of crossover. So any sort of papillae that contain taste buds anterior to that are going to have their sensations carried in the facial nerve. Anything circumvallate backwards is going to be carried within the glossopharyngeal. Okay, so these are serous secreting glands. These are known as von Ebner's glands. These are responsible for the secretion of the enzyme lingual lipase, but they're also responsible for helping to flush out these crypts. Because if you imagine, if you have something to eat, it comes down into these crypts, it's tasted there, and then it can stick around because it's a deep, relatively deep crypt. So these flush out these regions so that you're not tasting something 12 hours after you ate it, hopefully. And that allows new taste sensations to come in. Okay, so you can see that how vast these von Ebner's glands are here, releasing into the base of these crypts. These are the ducts, and then these are the secretory portions of the von Ebner's glands here. And then we've got some minor salivary glands associated here as well, some of these little mucus acini. So the tongue also has accessory salivary glands. Lots of, you can see down here, we've got some of these mucus glands, and then we've got some of the serous ones over here as well. So they're all contributing to the production of saliva in the oral cavity. Okay, well hopefully you found this stream useful. We really appreciate, does garlic get stuck in the crypts? You can smell it out. Yeah. My sons eat garlic bread, and you can actually smell the garlic from their skin. I'm not exactly sure how that works, but it's one of those substances which goes around. True Blue, hi Jamie and James, this was really cool, allowed me to annotate my slide box. It was great to see you guys answer people's questions with the slides on screen so you could show what you were talking about. Oh, it's my pleasure, and as I say, we hope to have this as a regular weekly stream. We just need to find a time that's best suited for everyone. So for those of you who are in my second year class, thanks Luke, Annabelle. This was the most ambitious crossover ever. Thanks very much. Hopefully you found it useful. Yeah, please tell your friends. We hope to build a nice community here to talk about histology and help everyone out. Yeah, so as I say, we will be back, let's hope next week. You're welcome, Buttons. Thanks for hanging around and watching our stream. We really appreciate it. I'm hoping to upload this to my YouTube channel, so if you want to make some comments or whatever, either email me or tweet me at Chapman _histo. No worries, Red Cherry Waves. Thanks very much for coming along. I really appreciate everyone coming along today. Those of you who are watching this recording after, not live, hopefully you found it useful as well. Yeah, I really appreciate everyone coming along and hanging out. It's been fun. I really love talking about histology, so you know it's actually a joy for me to actually come in and talk to you guys, answer questions. So many questions. Really great idea, thank you. Super useful to watch you explaining what you look in the slide. You're welcome. As I say, I think modelling is a really helpful way to learn histology, and having a live ability to ask questions is a really cool thing as well. So hopefully, thanks Dr. Kath. Thanks very much for coming along. I'm glad you found it useful. Yes, Ariel, please ask me another question. We'll wait while Ariel types in their question. Yeah, so as I was saying, I really enjoy teaching histology, so this is really fun for me. I love technology, and so...
Right, so it's there now.
Right. Enteroendocrine cells secrete gastrin as said in the notes. Yes. But this is specifically only G cells, right? Correct. But the... G cells aren't the only enteroendocrine cells that exist in the GIT. So we have other enteroendocrine cells which secrete things like histamine. We have secreting cells in the small intestine, cholecystokinin secreting cells in the small intestine, gastroinhibitory peptide secreting cells in the small intestine as well. There's a number of hormones being secreted in the gastrointestinal tract and then by the enteroendocrine cells. And I'm sure you'll get it again with whoever's lecturing you on the GIT physiology. I'm sure it'll come up again.
William Connolly, I think,
William
is doing
Connolly,
those, the
yeah.
enteric nervous system and things, but we might touch on it here as well.
Yeah, of course. We'll probably discuss it as we make our way through. But G cells, you're right, they only secrete gastrin. They're predominantly found in the stomach, but they can be found in the small intestine as well. But as I say, predominantly within the stomach, throughout all of the gastric glands there, the cardiac, the body fundus and the pyloric region. But hopefully we'll get to that next week if you want to come along and we have another repeat stream. Okay, so thanks very much for tuning in. We've gone 10 minutes over time, but that's great. Means everyone had questions and we're engaging, so I really appreciate. Tune in next week for more stomach stuff. So thanks for tuning in. I hope you enjoyed it, and we'll look forward to seeing you in our next stream next week. All right, thank you.